We've come to the third method of proofs of plane geometry using midpoint theorem. Let's recall what we have learned previously. For midpoint theorem, it starts off with if P and Q are midpoints of A, B, and AC respectively, then there are two results. The first result is that PQ will be parallel to BC. And secondly, PQ will be half of BC. So now let's go back to the question. In the trapezium ABC, AB is parallel to DC, and P and Q are the midpoints of AD and BC respectively. We'll start with part 1. How do we prove P is a midpoint of BS? Can we use midpoint theorem yet? Remember, for midpoint theorem, we can only use it when we have a triangle like this. But in this case, the midpoints are found in a trapezium, not a triangle. So for part 1, we cannot use midpoint theorem yet. But one way that we can prove P is a midpoint of BS is if we can prove that PS will be equal to PB. And in this case, we shall use the congruency test. We can use ASA to help us. So by using ASA congruency, we can then prove that triangle PSD is congruent to triangle PBA. And since these two triangles are congruent, then we can say that hence PS equals to PB. Hence P will be a midpoint of BS. So now, how do we prove that PQ will be parallel to DC? So if we can recall midpoint theorem, there's a result of parallel lines from midpoint theorem. Looking at this diagram over here, can we use midpoint theorem's result to prove PQ is parallel to DC? Well, absolutely yes, because now we can actually have a triangle where we can clearly see that P and Q are midpoints of the sides. So, since P and Q are midpoints of BS and BC respectively, and we have proven that, then by midpoint theorem, we can actually show that PQ will be parallel to SC, which means that PQ will be parallel to DC, since DC is part of a line segment of SC. So we're officially done with part 1, and now let's take a look at part 2. How do we prove that PQ is half of AB plus DC? Does this half look familiar? So remember that midpoint theorem has another result other than parallel lines, which is the half case. So PQ will be half of SC due to midpoint theorem. And we can actually split SC into two lines, SD plus DC. Why do I want to do this? Do you know that SD is actually equal to AB? This is due to congruency. I can replace SD with AB. And that is what they want us to show. So we are done with this question.